Hello, in this video we're going to be talking about glycolysis. So let's not waste any of your time. Let's get right to it. Now, when we're talking glycolysis, we want to think about is that this is one of the steps of cellular respiration. The idea of the oxidation of glucose, and there are typically 5, but the last 2 are put together because they're side by side and happening kind of in tandem. But it's the idea of glycolysis, pyruvate oxidation, the Krebs cycle, electron transport chain, chemoosmosis, and all these will have their own, for the most part, videos. So we'll talk in depth about each of them. Glycolysis, Krebs cycle. I mean, there's a little bit of ATP made, which is the whole purpose of this. But when we get to step 4, the electron transport chain, chemoosmosis, we're going to see a bunch of ATP made. It's in that metaphor that I used in 6, and you'll hear a bunch in class. The idea of investing a little bit, getting a bunch in return. What do you think about it as a firecracker? A little bit of energy used to make it, but a huge explosion. You think about the idea of the mythical machine that I refer to, where you put $1 in and get $5 back. You can take one of those dollars and put it in the machine and get $5 back. We would all do that all day long. But what you're going to see, is great as it sounds, getting a $5 bill back, what you're going to see is that ultimately the metaphor should be that I put a $2 in the machine and I get $36 out of the machine. And we certainly would, all of us, do that. We wouldn't go to work. We wouldn't go play. We would just stand at that machine and just put those $2 in as often as we can. Then we can go play. Alright, so what we're looking at here, and it's not a big thumb, no. This is the left side of a mitochondria. And what you see here is the locations of all of the different steps of cellular respiration. And whereas we go through each step, you can see that we get deeper and deeper into the mitochondria until we almost work our way across the other side, but not quite. So the things to think about are the locations, and these are important because these are certainly multiple choice potential questions. But the idea of glycolysis happening out in the cytoplasm of the cell, and then the glucose molecule moves into, or what's left of it, moves into the mitochondria, inside that initial membrane for pyruvate oxidation, and then into the past the second membrane, into the inner membrane inside of that middle section for the Krebs cycle, and then it moves off a little bit further to the other side, the membrane, for the ETC and the chemoosmosis. So each of these locations are important to know where things are happening. Again, if for no other reason, because they are potential multiple choice questions. But you're going to have other places to see this information, but just start putting in your mind these locations connection with the steps. Alright, so glycolysis, and again you can see kind of a grade version of that thumb, but the thing to think about is glycolysis happens in the cytoplasm. It's actually outside of the mitochondria. And the whole purpose here is to take one glucose molecule, which has 6 carbons, which we're going to see examples of, or what that means or looks like. And it's going to be broken down into 2 3-carbon molecules that are called pyruvate. That's the end product of glycolysis. And this is the 10-step process. But other end products, besides the 2 pyruvates, there's going to be 4 total ATP made. Okay, and it's got 2 net ATP because we're going to use 2 to get the whole process started. So we're going to use 2, we're going to make 4 for a net of 2. And then we're also going to have 2 NADHs. So we're going to see our first look at those electron carriers. Basically, two friends are going to come along and get 2 truckloads full of your stuff to help you move. NADHs are going to be made. So for glycolysis, when it comes to end products, you want to be thinking 2s. Okay, 2 pyruvates, 2 net ATP, 2 NADHs. And again, these end products are important to just essentially memorize because they are also highly potential multiple choice questions. Alright, so here is an initial breakdown of glycolysis from a information standpoint. The next slide we look at has a breakdown of the 10 steps, which we'll do here and we will certainly do in class. But you want to think it's glycolysis as 2 parts. They're not easily, it's not broken into half, but there are 2 parts: your investment stage and your energy producing stage. Just like if you go to you're at the mall and you've got a little kid and they want to ride the rocking horse or one of those cars or a train or whatever, those little carnival type ride things. You've got to put some money into it first, and then the machine kicks into gear. This is the same way. You got to use something to get them started. And in the energy investment stage, those 2 ATP molecules are used, and those phosphates are removed, energy is released. That's exergonic. Okay, and then an inorganic reaction occurs because those phosphates are added to the glucose molecule. So we've got redox going on, we've got the 2 reactions going on. As we've talked many times, these things happen in tandem, and right off the bat, boom, there they are. The second stage of glycolysis is the energy producing stage, and you can see the yellow ATPs there in the diagram beside me. 4 ATP molecules are made, and again 4 made, you use 2, so you got a net of 2. So again, and you can see the NADHs, but they're coming along, and an enzyme. We saw an example. We saw a picture of this. They will attach to an enzyme. The glucose molecule will be attached to an enzyme, the same enzyme, and those H's will be removed and put onto the NAD molecule. And that will happen twice. The thing to think about is that when that 6-carbon molecule is broken into 2 3-carbon molecules, now you have 2 lines, and both are happening simultaneously. But what you want to also think about in the future through the rest of these stages is that now there are 2 molecules that are being worked on instead of 1, and so the pictures will always show one of them, what's happening to one, but it's also happening to the other one. So when you look at a diagram, like the Krebs cycle will be a good example, and I'll point this out. If you look at the diagram and then you look at the list of end products, the numbers don't match up. The end product list takes into play having 2 of the molecules, but what you'll see in the picture is just the one. So you just got to recognize that, but I'll point that out at all times. But again, we're making 2 ATP molecules, or net 2. We're making 2 NADHs, and we've got 2 molecules of pyruvate. All right, so here is a list, or here is the 10 steps that I promised you, and it starts at the very top, far left, in that corner right here, right beside me. That's the glucose molecule, and you can see the ATP molecule is being used. The second ATP molecule is being used to start the process. And the words in red, those are the enzymes that are doing this process. And again, I won't ever ask you the names of those. That's too depth. We want to understand what's happening, not a memorization of each little part, but but just recognize that's what those are. And you can see the split down there at the very far end. Aldolase splits the molecule into those 3 carbon molecules. And again, from this point there, you got to recognize that what's happening to one is happening to the other. But you can see with the NADHs, that's in green down there. And again, you only see one, but you know 2 are being made, and it's because it's happening to the other molecule as well. And then you can see along the bottom row, coming back towards my picture, the 2 ATP molecules being made, but recognize that there are a second molecule that is happening to, so for a net of 2, making 4 total. So those are the 10 steps, and we'll break those down in class in a much deeper manner. But let me talk about a test question hint, because it always comes up. Somebody gets caught by this. The multiple choice questions can talk about the breakdown of glucose in products in a couple of ways. It can mention a particular stage like glycolysis, like Krebs cycle, like ETC or chemoosmosis. If it mentions a particular step in the process, then it wants only end products for that step. But if you look at the question and it doesn't mention a particular step, then it wants grand total numbers. So like if the question says during glycolysis how many ATP are made, it wants 4. But if it says a breakdown of glucose but doesn't mention the step, then it wants grand total numbers, and that will be 36. But so again, I just want to point that out. So be sure when you're reading those questions, you've got to identify, are we talking about a particular step or particular grand total numbers? Alright, so here is, and if it's in the PowerPoint, we'll point these out in class. You've got these summary stages, and again, this information we've seen, but these purple boxes are going to be the ones that you really want to pay attention to, because they have all the information, and each step has its own, but it builds it as it goes. And so when we get to the end of the PowerPoint, slide 44 is the one that has all of them, and when we get to that slide, we'll point that out as well. But you can see in those purple boxes, we've got glycolysis, the state, we've got the cytoplasm name, we've got the starting materials, and we've got the end products, those 222s. So when you think glycolysis, you want to think 2s, 2 pyruvates, 2 ATPs, 2 NADH molecules. And this diagram here, you'll see sprinkled throughout the PowerPoint. It's the whole process, and it just kind of, as you follow along, you can get to each, but you can kind of see the end products down there. 6 carbon dioxide are eventually going to get made, 10 NADHs, 2 FADHs, 4 ATP, until we get to the very end. So we'll see these sprinkled throughout, and it's kind of a summary. Here's where you are, kind of a map. Well, that's our video for glycolysis, part 1. When we come back next time, we'll be looking at part 2. So we'll see you then.